Let me just erase everything. Okay, well, welcome back, everyone. This is day 2 of 5.07. Also want to point out that yesterday's lesson, day 1, there was a mistake on number 3. The work going with the problem is wrong. And if you look at the original problem and the work that I have, you'll see my mistake and you can easily fix it. All right, so bell work, this is just to go over old concepts, just to make sure you know how to convert between one versus the other. So r, square root of r, you can rewrite as r to the 1/2 power. R, cube root of r, you can write as r to the 1/3 power. The cube root of r squared. So I'm going to do it in 2 steps, but you really, it's better if you do. We're going to have r squared raised to the 1/3 power. And what do we do when you have a power to a power? What do we do? Multiply. Yep. So this becomes r to the 2/3 power. You have the 4th root of a square root of r. So you just go inside out. So this is going to be r to the 1/2 power raised to the 1/4 power. And again, power to a power, you multiply. 1/2 times 1/4 is 1/8. And then for the last one, you have the 5th root of a cube root of r. So same idea. We're going to have r to the 1/3 raised to the 1/5 power. And a power to a power, you multiply. So that's why it becomes r to the 1/15 power. All right, so that's just a quick little review on converting between like the 2 forms, the radical looking form versus the exponent form. Any questions on that? Oh, easy review. All right, so we're going to use that idea later on this lesson, and reviewing this is probably going to be good when we actually get there, because that shouldn't be hard. All right. All right. Does anybody here speak French? Chloe, can you pronounce that for me? I know how to pronounce it. I'm just want to make sure that before I say it, I'm going to say it right. So if you do speak French almost fluently, I would love to hear you say this for me.
So it's pronounced DeMoivre.
You are correct. Yes, and you have an excellent accent. I can't do that good. It's DeMoivre. It's like the V. It's like just a subtle v sound. It's not vrai. It's not moivre. This is French, so just like it's moi, like me in French, moivre. But Chloe did it beautifully. I could never top that. So well done. All right, 5.07, DeMoivre's theorem and root on or of complex numbers. I took 3 years of French when I was in high school. Doesn't mean I can pronounce that with a French accent, though. All right, we are being recorded. What do I have we need? Yeah, just paper and pencil. All right, we have 28 slides. We're now on page 5. All right. All right, so the DeMoivre's theorem, we are going to, so there's, I guess, 2 forms of it. We are going to find the power. So it's kind of like an expansion of a complex number. but you first need to convert it into polar form. So when you have a complex number in polar form and it is raised to the power of n, to calculate that, it's very easy. All you're going to do is raise the r value to that exponent, and then you're going to multiply the angle theta by that exponent, and that's it. It's that easy. So this is the expanded form, and this is the condensed form, what it would look like. So again, when you have a complex number, it must be in polar form, which it is here, raised to the nth power. To calculate this, you are going to raise the r value to that exponent, and then you're going to multiply the angle by that exponent. And then that's your answer. It's that easy. So again, convert to polar. Use the I'm gonna say DMT for short because I can't pronounce it as well as Chloe. And give your answer in complex format. This is rectangular complex number format. All right, so here I have 4 examples, and these are already in polar form. So let's go ahead and solve these. And I will have these 4 problems on the next few pages. Give me a second to write them down, though. Okay, I have number 1 and 2 on this page. We'll do the first one together. I'll give you time to work on number 2. All right, so the steps again. We are in polar format already for this complex number. We are going to raise the r value, which is 3 to the 3rd power. And then we are going to multiply theta, which happens to be 3 pi over 2, by the exponent. So there's the setup. And then we do 3 cubed is what? What's 3 cubed? 27 maybe? 27, yep. And then 3 times 3 pi over 2 becomes what? 9 pi over 2. Yes, this is starting off so easy, right? The hardest part about this lesson so far is pronouncing that word. Unless you're Chloe. So there's the answer. And if you wanted to write it in, and we have to now convert it into rectangular form. So I'm going to write it in expanded form first. And now we just do the parts. So I think yesterday, did I skip converting from polar to rectangular? I feel like I did, and I shouldn't have. I did skip it. I did skip it. Whoops. But it's easy, so it's okay, right? Yeah, I shouldn't have skipped it. I don't know why I thought I had to skip it. All you got to do is, well, you can type it in cosine of 9 pi over 2, hit enter, or use the unit circle. But typing in would be way easier. So make sure you're in radians. So cosine of 9 pi over 2 becomes 0. And then you type in the sine of 9 pi over 2, hit enter, and you get 1. And now what do we do? Wouldn't the I? No. So I is always last. So whenever you're talking about like a number that has the I variable in it, I is always last unless there is a radical in there. Radicals are last even after the I's. So yeah, one I. Mm-hmm. All right. So what do we do next? Distribute. Yep. 27 times 0 and 27 times 1I. There you go. See? So I killed two birds with one stone. We went over what I skipped yesterday just now. That easy. All right. Let's we'll do this one together again. And then the next two I'll have you do separately. All right. So all we're gonna do is 3 to what power? 3 to the fourth. Yep. And then what? Multiply what by 4? The radian. Yeah. Okay. Yeah, I thought radical when you said rad. Okay. Radian. Yep. There's the setup. 3 to the fourth power. I think if you type it in, I think it's 81 maybe. It is 81. Yep. And then 4 times pi over 4 is just pi. Oops, that got cut off. All right, then we're going to write this shortened form into the expanded form. So we're going to have 81 times cosine of pi plus I sine of pi. Oh, and by the way, so along with radicals being after the I, trig functions also go after the I. All these little rules. All right, then you can use the unit circle or you can just type it in, cosine of pi and sine of pi. So you'll get -1 for the cosine and you'll get 0 for the sine. And then you will just, well, really can do it in your head, right? Because 0 times anything is 0, right? So this term goes away. And then all you're going to have left is 81 times -1, which is -81. So yeah. Any questions on these two before you do them yourself?
So basically, converting from polar to rectangular is just like basically simplifying it, right?
Sort of yes, kinda.
Expand it and then do the
Right.
cosine and sine and then distribute.
So just to kind of recap of converting from the polar answer to rectangular, if you write in the shortened form like this right here, 81 CIS pi, this is the answer in polar form, but we want to write the answer in rectangular. So you need to rewrite this in expanded form, which is this, right? And then
Right.
kind of
Yeah.
what you're thinking is you just do the parts, right? Use unit circle if you can, or you just type in this part here. Cosine of pi is -1, sine of pi is 0, and now from this point you just distribute the 81, and then you get your rectangular form.
Yeah. Okay. Thanks.
Yep. All right, everyone, try number 3. I'll give you 2 minutes if I can find my phone. If you finish number 3, go on to number 4. All right. If you are done with both of these problems, choose D. If you're only done with the third problem, choose C. And if you're not done with any of them, choose B. All right. Looks like everyone's done with at least one of them. All right. What did everyone get for number 3? What's the answer? That looks like a nasty answer. Maybe that's why no one wants to type it in. Negative 81 over 2 plus 81 rad 3 all divided by 2. And then you forgot your I. Oh, yep, you forgot your I. Yep. And that's correct. Yeah. So that is the correct answer. Oh, geez. All right. Now remember, for a complex number, it has to be in this format, a plus bi. You could technically have this I between the 81 and the rad 3, but your quizzes and your test, they want it in this exact format. Your A value, your B value, and then the I at the very end. There's the work for it if you're curious. All right, let me give you one more minute for number 4, and then we'll go on. Number 4 is much easier to type. So your test will want it in this form where you have your A value and then plus or minus your B value, and then I tacked on at the very end of the fraction there. Your test also wants you, if your fraction is negative, they want it in front versus on top. But it doesn't matter if you're grading it by hand. I like having the negative on top personally, the numerator. But your test likes it out in front of the fraction. So I know on past tests, people have missed problems where the negative had to be in front and they put it in the numerator. And some people message me saying, "Hey, I typed it and it marked it wrong because they wanted it in front. Can you fix it?" And I said, "Yeah, I'll fix it." The problem is I don't have the time to check everyone's test to see if they missed that problem because they put the negative in front versus on top. So always review your answers to see if maybe you got it right. It just graded it wrong, and that happens. So it's up to you to catch it and let me know. Yes. So on your test, Chloe, it's going to make it easy for you. It's going to have blanks where you type in. So let me give you like example. It'll be like this, and it'll have like a blank box right here, and then it'll have like the plus sign, and then it'll have a blank box, and then it'll have the I already typed in there for you. So all you gotta do is fill in the two blank boxes, and that ensures that it won't mess up the formatting when it grades it. So
Are we
don't worry,
supposed
don't
to
worry.
have a decimal in the second one in number 4?
I did not get a decimal. I did get a radical for the I term, but no, it should be. I got an integer. Yeah.
Okay, yeah, because I'm getting a decimal for one of the parts, and I don't know why.
All right. So, what did everyone get for their answer for this one?
I didn't finish because my calculator was supposed to give me the answer for a part of it.
It's a decimal. Oh, geez. Maybe I did it wrong. Somebody else have an answer?
See, I did the when I typed in 256 times negative rad 3 over 2, I got a decimal.
Well, let's work it out together and see if maybe I just made like a mistake somewhere and it is a decimal. Let's take a look. All right. All right. So we're going to do 4 to the 4th power, and we're going to multiply theta by 4. So let's see what that looks like. So far, so good. Okay. What is 4 to the 4th power? 256. Okay. And then 4 times 4 pi over 3, what is that? 16 pi over 3. I also agree. Okay. All right. Now we're going to write this in expanded form. Now, I wonder if I just typed it wrong. Let's find out. When you type in the cosine of 16 pi over 3, you hit enter, what do we get? So I also got negative 1/2. Okay. And then okay. So you actually can't type this in. I think if you type in sine, so when you type in sine of 16 pi over 3, what do you get? Okay, it does give it to you. Okay, so negative rad 3 over 2, and that's what I got as well. So now what do we do? Distribute. Okay, so what's 256 times negative 1/2? Negative 128. Yep, I agree with that. Oh, I actually, my answer is a mistake. I typed the answer wrong. What is 256 times negative rad 3 over 2? It's okay. So if your calculator is giving you a decimal, you have to do it by hand. Well, it's not that hard. So if you think about it, looking at this, you just distribute, right? So multiply the top by 256. So you're going to have a minus and then 256 rad 3 divided by 2. Let me write that down next to it. So that second term is, so you're going to have the minus 2, 5. Thank you, Neuro, for making this so easy on me. I want to delete it. All right, let's try that again. So you're going to have negative 2. Oh my goodness. 256 rad 3 all over 2. So what's 256 divided by 2? Negative 128. So you're going to have minus 128 rad 3. And that's what you put. I put plus because I don't know what's going on in my math life. So that should be a minus sign. Just going to do that, and I will then change it to a minus sign. Okay. Like it never happened. And that's the answer. All right, everyone's happy with the answer?
Is the Casio FX115 able to do that? Because mine was giving me a decimal.
So when you type in 256 times negative rad 3 over 2, you hit enter, you get a decimal.
Yes.
Right? There's a button that says S to D.
Yeah, I pushed that and it doesn't do anything.
Okay, then apparently it doesn't know what's going on. So hopefully you know what's going on and you can actually fix that by just leaving out the rad 3 until you simplify 256 over 2.
Okay. Thank you. Sad though.
All right. So I have more examples. So we want to find the following powers in rectangular form, but we just did like a bunch of them. Why do I have so many examples? Oh, because these examples, you have to first do what? Convert to what? Convert to polar, yes. Yes. Someone hit back. Rude. Yeah, don't click around. I don't even know what page we're even on anymore. Okay. All right. Now, whenever you have like this and it's squared, would it be almost maybe just as fast if we just wrote it twice and foiled it? I think so too. I think if it's power of two, I would probably write this twice and foil it and simplify it. I think that might be faster. But when you have a power of four, five, or even like three, because you have to write it three times, or you got to write it four times or five times, multiplying that out is a pain, and that's where the DeMoivre theorem comes into play. It makes it easier, but you first have to convert it from the rectangular complex form to the polar complex form. So let's look at. Let's go to a difficult. Let's do number 7 first. We'll do a hard one first. Actually, it's not really that hard. No, let's just go in order. I changed my mind. I'm so indecisive. All right, so from yesterday, we have to convert this into polar form. So if we remember correctly, how do I find the R value? What do I do? What do we do? The square root of a squared plus b squared. Yep, that's what we do. And that's how we get 5. And then how do we find the angle, theta? Arctan of b over a. Yep. So that looks like this. Ooh. Now, if you type this in, do we get a nice number like we have been in the past? You sure don't. And how does that make you feel? Like this? So you do have problems like this on your in your module, and I believe you might actually have a problem like this on your quiz, but you won't see one of these on your test. If that makes you feel a little better. All right, and you want to avoid using rounded work in your problem. So even though I wrote this out to whatever places this is still considered rounded work. So I don't want to use this number here for theta. I want to use the exact value of theta, and the exact value of theta is the arctan of 4/5. So that's why I wrote it here instead of, well, the rounded value. All right, now I'm going to do 5 to the 4th power and then multiply my theta, which is this, by 4. I'm then going to write it in expanded form. Well, after I do 5 to the 4th power, apparently. And now what you're going to do is you're going to type in the cosine of this. So what I would do is, since we're probably going to go basically right to the answer, you want to skip this step here, unless I actually did 625 times both of those and I showed it. I don't remember if I did. Oh, I didn't. Oh, actually, it comes out very nice. Everyone type in the cosine of 4 arctan of 4/5 and hit enter. I had forgotten this actually comes out really nice. It. So we're typing cosine parentheses 4 arctan parentheses 4 over 3 in parentheses, and then hit enter. All right, so what Emily wrote in chat is what you get. Negative 527 over 625. Yes. And then type in sine parentheses 4 arctan parentheses 4 over 3 in parentheses, and hit enter. Negative 336 over 625. I agree with that. This is actually a good reason why you don't want to use rounded work. If you actually made the mistake and replaced this with this long decimal and you type that stuff in, you would not get these fractions. You would get a decimal. So always use exact work, round the final answer. And the last part's pretty easy. Distribute this times this fraction, and then this times this fraction here. So maybe this problem wasn't too bad. And only
would there be a
really?
negative sign over the 336?
That's what I was going to say too, because I got negative 336.
Yeah,
Why do I make these mistakes?
because we're smart.
And are you implying I'm the
No.
opposite?
No.
Yes, which means everyone else in chat agree with my mistake. Needs to be fixed. Did that 2 in a row. I'm just gonna put a box there. Yeah, that's basically a minus sign, right? Okay. All right. Yes. Let me fix my. Okay. All right. This problem's kind of tricky. All right, I'm just quickly go through this. This is from yesterday's stuff, but this is good practice to convert from rectangular to polar form. I'm just going to quickly go through it because that's not the point of today's lesson. But I do want to point out this original point is in what quadrant? Negative 4 minus 4i. Which quadrant is that? It is in quadrant 3. Okay. So that means when we convert into polar, we should also be in quadrant 3. But when you do the arctan of negative 4 over negative 4, you get pi over 4. Which quadrant is pi over 4 in? It's in quadrant 1, yes. So how do I make that correction to put it in quadrant 3 from 1? You're just adding pi to it. You do a half a rotation. So you do pi over 4 plus pi. Type that in, hit enter, and then you get 5 pi over 4. So this is a good reminder from yesterday that you need to check which quadrant you started in and which quadrant you ended in to make sure that they are in the same quadrant. If you don't do that check, there is a good chance you're going to miss the entire problem. So yeah, so remember adding pi or adding 180 is the same thing. However, we're dealing with radian values, so you can't add 180 to the radian angle because they're incompatible, right? It's like knowing the conversion for inches and millimeters, and you add millimeters to inches or vice versa. They're not compatible units. So remember that. All right. And then I had this long explanation here. Let me make sure it makes sense before I show it. I'm just going to show it. It's really wordy. What did I do that this night I made this lesson? So given the point is in quadrant 3, the angle found is in quadrant 1. If you do not use the found reference angle to find the angle in quadrant 3, you're fine. Okay, so I just wrote what I just said. Oh, and that last little after the dot dot dot, we'll see. Yeah, that's actually for the second part. So we'll pretend I didn't show all of it. How about that? All right, so now we are in polar format. Now we want to do this squared. And again, when you have something squared, it would honestly be probably easier is if we wrote this twice and we just FOILed it and simplified it. Like we're doing a lot of work for such an easy problem, right? But just spoiler alert, your test won't be an easy problem like this. I won't use the power of 2. It'll definitely be like a power 3 or higher. So yeah. All right, so just like we've been doing, you take the R value, we're going to, in this case, square it, right? Make sure you have it in parentheses. If you forget parentheses around the 4 rad 2 and you did 4 rad 2 squared, when you type it in, it thinks you are just squaring the radical and not the entire piece. So that's important. And then multiply the theta by 2. 4 rad 2 squared is 32. And 2 times 5 pi over 4 is 5 pi over 2. We're going to write it in expanded form. And then, well, you just type that in, cosine of 5 pi over 2 and sine of 5 pi over 2. You'll get 0 and 1 respectively. And now distribute. So, and if you were to write that twice, you FOILed it, you get the exact same answer. Knock yourself out. All right, now for this second part here, I wanted to point this out. If you forgot to adjust from quadrant 1 to quadrant 3, and you forgot, and you still went through this problem, your answer would actually, in this case, be the same. And that's because of the exponent of being a 2. If that was an exponent of 3 or higher, it probably wouldn't be the same answer. And I actually I went through this and I tried different scenarios and it wasn't. So you need to adjust for the correct quadrant. Okay. So number 7, let's I'm going to give all of you 2 minutes to convert from rectangular to polar. I have it on the screen. Mistakes were made. Nothing to see here. Nothing to see here. Thank you, Emily, for pointing the obvious that I didn't cover it. And since I already showed it, I'm just going to show it again. So if you got to that point, keep going on with this problem to finish it. I'll give you, say, a minute and a half to finish this problem. All right, in chat, please write your final answer. People are still finishing the problem, I think, right? Okay, so it looks like Emily said 3,888 rad 3 plus 3,888 I. And that sounds right. Let me take a look. You got plus. You got the plus between them. My signs have been backwards all day long. So if you got the plus, well, double check yours. So the sine of 25 pi over 6, is that plus or minus? It's positive? Oh, boy. I don't know why I'm writing my signs backwards today. I have no idea. And I think I'm going from, I even put a plus sign here, but then when I wrote my final answer, I put a minus. I don't know. I don't get it. That is a plus sign. There we go. Like it never happened. No mistake today, of course not. Mistakes. All right, and then I think just like the last slide about making your correction for the quadrant, and that if you forget to make the correction, then your answer will be totally wrong. All right, I'm going to skip these because I want to go on to something else. I'll come back and I'll just show the work at the very end for number 8. Number 8 isn't anything special. It's done the same way as the last one. So I'll skip that one for now. Let's go to the last part of this lesson, which is this, which is pretty easy too. All right, so to determine the complex cube roots of this, for example, so if I have x cubed equals this, and I want to find the cube root, so I'm cube rooting both sides. When you cube root this, you get x. When you cube root this, just like the bell work, I can write it as in radical, the cube root radical form, or I can write it as the cube root exponent form, and that's what I'm showing here. So this would be the answer. The thing is, you can't say, all right, this is my answer. So we're going to use the DeMoivre's theorem to actually help us solve this. Because looking at this in rectangular form, the cube root of this complex number, in my head, it sounds impossible. And the fact that somebody figured out this theorem to do this, I think is amazing by itself. All right, so we're going to use the other variation of DeMoivre's theorem for the nth root. All right. That formula is what you see here. So this is z sub k is equal to the nth root of your r value times the cosine of theta plus 2 pi times k all over n plus I sine of theta plus 2 pi k over n. Now, your k value, because we're going to have to do this. So if I want you to find the second or the cube root, we would go from k from 0 up to n minus 1. And if we're doing the cube root, n would be 3. So 3 minus 1 is 2. So we do 0, 1, and 2. And you'll see that on the next page here. So we're doing the cube root of the complex number -1 plus I rad 3. So we first need to convert this into polar form, which we know how to do from yesterday. So we find what r is pretty quickly. You get 2. We find theta, so arctan of b over a. You get negative pi over 3. Now your theta, it needs to be positive. So let's look at this. -1 plus I rad 3. Which quadrant is this in? It's in quadrant 2. The angle that we found by typing this in, hitting enter, negative pi over 3, which quadrant is this in? It's quadrant 4. So what do I do to go from quadrant 4 to quadrant 2? We're just going to add pi to it. Yep. So then we get 2 pi over 3. So now we are in quadrant 2 like we're supposed to. So that's the important piece. It's also, the very beginning of converting from rectangular to polar is probably the hardest part of the problem. The rest is just plug and chug. So to find your first roots, remember, we go from k equals 0 up to n minus 1. So we start at 0, then 1, and then 2. So that's a total of 3. If we're doing cube roots, you should have 3 answers, 3 roots. We do. Here's one of them. Here's another one. Here's the third one. So 0, 1, 2. Is that clear of the numbering? All right. And then we just plug the stuff in. So we just write it. K is 0, N is 3. So the K value is the only thing that you are going to change. K is 0 here. And that should have been blue. I don't know why it's not. So K is 0. So when I do this down here, my K will then be 1. And then for the other one, my K will be 2. You could also do this problem in the shorthand form, and it'd be a lot less to write. And I think I show that on the next page, but we'll see. All right, so then we just, you just solve all the parts. You're going to type in the cosine of this over 3, hit enter. Type in the sine of this over 3, hit enter. And you should get that. And then we go through the other 2 and just type those in and hit enter. So it's just plug and chug. That's it. The hardest part of this problem is converting it from rectangular into polar form. That's the hardest part of the problem. The rest, you're just using the formula and you're just plugging stuff in to set it up, and then you just type it in.
What does the n minus 1 mean at the top? Yeah.
Right. So this is the formula, and
Yeah.
you're having to do this more than once, like we did 3 times here. The n value. So since we're doing cube root, your n value is 3. So you want to go from k is 0 up to, well, since n is 3, 3 minus 1 is 2. So it goes from 0 to 2, 0, 1, and 2.
Okay.
Good?
Yep. Thank you.
Mm-hmm. And I think on the next page, yeah, I started covering it up and I just didn't realize why I was covering up since it was the same question. I just redid the same problem in shorthand form. And does writing less make the problem look easier? It looks pretty, yeah, it looks easier. It's the same exact problem, just written in shorthand form. So your work, when you do your modules, your practice problems, your quiz, your test, I would recommend doing this problem in the shorthand form because you're writing less and it has the same meaning. So yeah, this is the exact same problem. And then the answer is also written in shorthand form. But this page and this page, this is the same problem. Just this is a longhand form versus a shorthand form, just to let you know. Your test wants all of the answers in shorthand form, and you'll see that. But your quizzes, for whatever reason, doesn't. Like on your quiz, they want you to put this form. So instead of doing the radical form, they want you to write it with exponent form. But on your test, they want you to leave this in radical form. I don't know why they go back and forth. It's like they had 3 different people like work on this unit. the modules, the examples, the quizzes, and the test. It's pretty clear to me it's not the same person working on this, just because of how kind of random it is, of how they present teaching it and the examples and the quiz and the test. I don't know. It's driving me nuts. I try to do my examples of how they model it in the module, so there's no surprises, but they keep changing it up. So I was surprised the entire time. But anyway, let's keep going. Yeah, there's no consistency. I agree. All right. So I have 4 examples. I'm probably going to skip some. Let me see what I want to skip. Hang on. All right, let's do one. Let's do one of these. So these 4 examples, it's already in complex form, so it saves us that step. Let me pick one of these to do. Let's do number 9. So number 9, I want us to find the 4th root of this. So n is 4 means I want us to find the 4th root. N is 3. This is the cube root of this. The 5 is the 5th root of this. 2 is the square root of this. So let's do number 9. I'm quickly just going to show the oh, it's already converted. Jumping ahead. All right, so since n is 4, your k will go from 0 to n minus 1, and n is 4. So we're going from 0 to 3. So we have 0, 1, 2, and 3. And I would suggest setting all of these up first, because if we're doing the 4th root, you should have 4 answers. And if you set this up and we set it up 4 times, 1, 2, 3, 4, you're doing good. If you only do this 3 times, we're missing one. If you have 5 and you look back and you say, hey, I should only have 4, well, you did too many, right? So 0, 1, 2, 3. And all we're going to do is just keep changing that k value. K is 0 here, k is 1, k is 2, and k is 3. I don't know why my blue formatting went away. Oh well, they should be blue. No, I made these numbers blue as well. So that should be blue, that should be blue, blue and blue, that should be blue, that should be blue, blue and blue. Yeah. So it lost the formatting when I saved my PowerPoint. It does that sometimes. It's weird. Oh yeah, those stayed blue. But those didn't. All right. It's sad. I agree. Yeah, so you would just type this in. So get that. So everyone go ahead and type this in. So the nice thing in expanded form, you don't have to type this twice because it's identical, right? And that's why doing your work in the shorthand form, it looks pretty and it looks easier. So none of you should type this in twice. You're just doing it once, right? So you type in 5 pi over 4 plus 2 pi times 1 all over 4. Hit enter, and then that's what theta is for this answer. And then do this one, hit enter, get that answer, and then same thing for the last one. So let me give you, I think, a minute. Hopefully it's enough to type all that in. It starts at 0. Yep. Yep. So remember, k always starts at 0, and you stop at n minus 1.
I think she means in the last problem, V3, it's still a 2 instead of a 3.
Typo. You're right. So many typos. Let me fix it. I see what you're saying. Yeah, so when I made this, rather than me retype everything again, I did a copy paste, and I thought I changed the numbers, but I didn't. Oh yeah, good catch. I'm gonna change mine real quick. PowerPoint. Everyone for being the guinea pig in pre-calc. So next year I'll have 0 mistakes. They're gonna think I'm really smart then. You're probably right, I will. But on purpose. All right, this first one. Typing 5 pi plus 2 pi over 4, hitting enter, what do we get? What is that fraction? So what's the fraction piece? You don't need to write the entire answer. I just want the fraction piece. 13 pi over 16. I agree. That's what I got too. Okay, typing in 5 pi plus 4 pi over 4, hitting enter, what do we get? So remember, we're just doing the part that's in parentheses. Don't include cosine with it because we're not converting it back into rectangular form. So also, here's something with inconsistency, right? Before using the DeMoivre's theorem, the answer had to be in rectangular form, right? But when you're doing the nth root of these problems, they want the answer kept in polar form. So yeah, there's no consistency. It's weird. I thought so too. Yeah. There's no pattern. I like patterns, and there's not one anywhere in this unit. Yeah, I don't know. I just do what they tell me to do. So again, what is 5 pi over 4 plus 4 pi all over 4 equal to? Now, if you notice, I said 4 pi, not 2 pi times 2, because it's less to type in if you just do the simple stuff. 2 pi times 2 is 4 pi. So you should type in 5 pi over 4 plus 4 pi, all divided by 4. Less to type out. Hit enter. 21 pi over 16. I agree. And then the last one. So the hard part about this problem, other than writing everything, is typing it in. And again, I would suggest doing this in shorthand. And after I actually, so I finished the test review, and I saw what was on the test and then how they wanted answers. And I saw that they wanted the answers in the shorthand form. I was going to go back and retype all of these. And then I said no, because that's a lot of typing. So I only retyped one of them on this page. So I said, all right, the test wants it this way. So I just did one of them because it was too many examples to go through. All right, any questions on this? I'm going to skip ahead and we'll do just one more and then we'll call it a day. Let's do a really hard one. Ooh, number 14 looks like a nightmare. Let's do that one. Number 14. Oh, and then I'll come back to the very end and I'll just show the answers for the ones that I'm skipping. So like number 10, you can work this out on your own. It'd be good practice. So make sure you do that. Yeah. So when I stop this, really, if you have the time, and you should find the time, because this week and next week, they're going to repeat. So we only have new lessons this week. And then starting Monday next week, on the schedule, it's the exact same lessons we had this week. So I won't have any new live lessons next week. So you're going to have time to kind of go over this material this week again next week. Hopefully that makes sense. All right, so there's number 10. Here's number 11. Here's number 12. All right. So these problems, and I'm really probably just going to go through one of them because I do have a lot of examples. So we have to convert these all into polar form. Right now it's in rectangular. And I said, which one looked like a lot of fun? Number 14 looks like a lot of fun. So 14 is a lot of fun, really for two reasons. One, A and B are fractions with radicals, so that looks like it's a lot of fun. Also, your n is 5, so we're going to have 5 roots. So this is going to be fun. Let's go to it. Look at all those blue boxes. Yeah, I would say our definition of fun probably differs quite a bit. All right, we got to find the 5th roots. So we want to find the 5 complex solutions to this problem. All right, so you first need to convert this into polar form. And I'm quickly just going to show that because we did this yesterday. But that is converting from rectangular into polar is a big part of a lot of these problems for 5.07. All right, so we have radical a squared plus b squared. We type that stuff in, we get rad 34. For the angle, we do the arctan of b over a. And don't forget, so something I want to point out is this minus. So b is negative, so don't forget your b. So again, Your B term is negative. So don't forget it when you set this up. It does matter. All right. You type that in, you hit enter. You get negative pi over 6. So let's look at something real quick. The original point, this minus this is in quadrant. Which quadrant is this in? This complex number. Looks like we got people that disagree. So the original point, which quadrant are we in? All right, we got 2 votes for quadrant 4. It is in quadrant 4, yes. So think about the argand plane, right? This is the real number is positive, so you go starting at the origin, you go to the right. So actually, let me draw that out. Argand plane looks like this. So we go right on the real plane, and then your b value is negative. So in the imaginary axis, we go down. So your point is going to be somewhere here, right? I don't know. It's obviously not the scale by any means, but it just shows that we're in quadrant 4. This point, this negative pi over 6, which quadrant is this angle in? It's also in quadrant 4. But there's a slight...
Dr. J,
Yep.
Can you go back a slide quick? Because Sarah's screen is being whack, and then go back.
Yeah. Better? Okay. So there's a slight problem. Even though negative pi over 6 is also in quadrant 4, the problem is it's negative. And for whatever reason, when you write your polar form, you want to keep the angle positive between 0 and 2 pi. And the problem should actually state the interval. And I think for the most part it does. I don't remember for sure, but it should. It should tell you that you're between 0 and 2 pi. And that way you know you're forced to have that theta value between those 2 numbers. And being negative, it's not. I didn't give that restriction. I should have, but it needs to be. So even though we're in quadrant 4, the angle is negative. How can I fix this? Yes, so Emily says add 2 pi, which creates the coterminal angle, and she is correct. So you're just doing a full counterclockwise rotation to make the angle positive, but we are still in the same location, hence coterminal angle, which we learned in unit 3 or 4. I don't remember. It all blends together. So we do want to add 2 pi to it. So the angle is 11 pi over 6, which is still in quadrant 4. So again, converting from rectangular to polar of a complex number, it's a big part of a lot of problems that we are dealing with in this section 5.07. You really have to have a good understanding of the quadrants from like Cartesian and argand plane. You also have a really good understanding of rotations. And if you do a full rotation, 2 pi, it creates a coterminal angle. And that's a way we can actually make the angle positive. You also need to understand when you do like arctan of whatever the values are, and you're in the quadrant diagonal to where we're supposed to. And just because of how the period of tan works, you have to do like a half a rotation to get in the correct quadrant. So this problem is a really good example to make sure you really understand what's going on all around. No pun intended, because we need circles all around. Math jokes, they're so bad. All right. All right, so the original problem converted into polar format is rad 34 CIS 11 pi over 6. This is the hardest part of the problem, is converting. The easy part is, it should be the plug and chug. So we're going to have, remember, we're doing the fifth roots, right? So we should have 5 answers starting at 0, going up to n minus 1. So 5 minus 1 is 4. So from 0 to 4, 0, 1, 2, 3, 4. And that's what we want to do. We want to set that up. Z sub 0, Z sub 1, Z sub 2, Z sub 3, and Z sub 4. All right, and then you just plug and chug. I'm just quickly going to go through this. So Z sub 0, you would do 11 pi over 6, all divided by 5. Hit enter, you get 11 pi over 30. For Z sub 1, you type in 11 pi over 6 plus 2 pi all over 5. Hit enter. You'll get that for your theta. And then so forth. So that the rest of it, just typing it in, hitting enter. So here's something kind of neat. Just how roots work and powers. If you were just bored enough and you wanted to take all of these roots, and I took this answer times by this answer, times by this answer, times by this answer, times by this answer, and if you were able to suffer through that work, you would get back to the original problem. But you would also want to use, yeah, actually you couldn't use DeMoivre because it's not the same theta. So yeah, if you were to multiply all 5 of these together, which I wouldn't even try it, you get back to the original problem. This right here. So, neat. Math is neat. And whoever thought of this theorem, genius. Genius. All right. Here's number 15. Here's number 16. So I encourage all of you to take the time, whether it's this week or next week, when we don't actually have live classes, to work through some of these and practice them. But let me just go back to where we left off on the blue boxes, and I'll just uncover the answers for all of you to see. All right, I think it was starting with number 8, but let me check. All right, yeah, starting with number 8. So here's number 8. And again, if you don't want to see this work right now, just close your eyes. I'm going to quickly just go through it just to show it. Watch the recording and work them out later. So there's number 8. And I really hope I don't have any typos. Oh, look. Okay, I have plus and plus and plus. All right. Maybe it's right. All right, number 10. There's the setup. There's the answers. Number 11. There's the setup. Here are the answers. Number 12. Here are the setups. There's the answers. Number 13. So converting from rectangular to polar. So that one required a full rotation to stay in quadrant number 4. And then here's the setup. And then here are the answers. Number 15. I don't know why I have so many examples. I got carried away, apparently. This is a lot of examples. I wonder if it's because I thought the modules didn't have very many. So here's the work to convert rectangular into polar. That one just has a correction for quadrant from quadrant 4 to quadrant 2, it looks like. Then here is the setup. The last example, number 16, converting from rectangular into polar. Here is the work. And then finding the nth roots. Here's the setup. And here are the solutions. All right, so I would say either probably next week, when you take the time to go through these examples, if you're not sure how I worked some of them out, or if you find that I just mistype something or whatever, let me know, and we can go through it together, whether it's a small group or one-on-one, because I will have time next week after the proctoring, because I'm not having live classes next week, to go through some of these with you if need be. But yeah, spend the time, and there's plenty of examples to go through. But yeah, they're fun. So thanks for hanging around, guys. It's probably dinner time for a lot of you, including myself. So thanks for coming in. As always, I hope you learned something. Oh, hey, Chloe, before I stop the recording, can you say DeMoivre's one more time for us? because you say it's so good. But if you don't want to, you don't have to. Pass. Say it again. We didn't hear you.
DeMoivre.
Yes, DeMoivre. All right, guys. Until next time.